All right, let's start this off. First question, little review. Can you guys find the sine ratio coming from angle A? But I want you to use Z, Y, and X, please. All right, use Z, Y, and X. Sine ratio coming from angle A. What is it? Using Z, Y, and X. Sine ratio. So using Z, the variable Z, Y, and X, what is the sine ratio coming from angle A? Coming from angle A. All right, start us off right here. Let's have a good day today. Lauren, what do you got? Good, Y over Z. Opposite over hypotenuse. Perfect. A little more challenging question now. You can talk with people in your group if you want. Find me another ratio that also equals Y over Z. So sine of this angle, cosine of this angle, tangent of this angle, that also equals Y over Z. All right, go ahead. Find me another ratio that equals Y over Z. So sine of this angle, tangent of this angle, cosine of this angle. Find me another one that's equal to Y over Z. So we already knew sine of A was equal to Y over Z. What else equals Y over Z? Give me another one that equals Y over Z. All right, I think we got one here. Where are we going? Test, there you go. What else equals Y over Z? So cosine of this, sine of this. You got this.
X over Z?
No. I want something that looks like this, like sine of A. So if you told me do sine of C, I go, no way, that's X over sine of C is equal to X over Y. I want something like cosine of this angle, tangent of this angle. See what I mean? I'll get back to you. Maybe it's telling that she wants to do it. Okay, here we go. Where am I going here? Cormac.
Cosine of C.
Okay, see where I'm going there, Tess? If you tell me if you do cosine of C, what's it going to be equal to? Adjacent over hypotenuse, which would be Y over Z. See what I mean? Okay, that's what I was looking for. So here's what everyone just told me here. This whole crew here. Sine of A is the same as cosine C. That's what you guys just told me, right? The sine ratio for A is the same as the cosine ratio for C. All right, probably even more challenging than the last two. Is there anything special about angles A and C here? And they're not congruent. I'll throw that right out. It's not congruent. But look at the diagram. Is there anything you know about angles A and C? The actual angles A and C. What do you know about them? And remember, this is a right triangle, so angle B is already a right angle. What do we know about angles A and C? And I'll take anything here. I'm looking for something specific, but I'll take anything. You're going to chime in, Lily?
They're less than 90 degrees.
They're acute, right? Okay, we're getting there. Yep, they're acute. I'm actually thinking about putting them together. If you take A and C and put them together, anybody know what they should always be equal to, Cormac? 90 degrees. What's that called if two angles equal to 90? Complementary, all right? So angles A and C, they are complementary. And that is the only time when this is going to happen. When the sine ratio and cosine ratio are equal, if and only if the angles add to 90. Okay, that is the only time those two ratios will ever be equal to each other, is if the angles are equal to 90. So I'm going to have you guys write down a couple conclusions here for me. First conclusion. If angle A and angle C are complementary, And again, I'm using A and C because that's what we used in the diagram above, but this could be any angle, X, Y, Z, H, doesn't matter. If angle A and angle C are complementary, ready? The sine ratio of angle A will always be equal to, how do you want to finish it? Go ahead, Lily. The cosine ratio of, bless you, cosine ratio of angle C. But only if those angles are if they add to 80, if they add to 20, they're not going to be equal. And make a little note here too. These two right here, you can switch these two. We can say the cosine of A would be equal to the sine, so it can be switched. All right, so just make a note that sine and cosine in this conclusion can be switched. All right, and the second conclusion I want. The second conclusion. Ready? I'm going to put actually, I'll use A and C again. No, never mind. If the sine of angle, Jonathan, just pick a random letter for me. If the sine of angle B is equal to the cosine, Bailey, pick another one.
C.
That's all right, sure. I just wanted to use new letters than A and C.
Sorry.
No, you're fine. We use B and C. So if the sine of angle B and the cosine ratio of angle C are equal, what do you know about B and C then? They have to be what? They have to be. Angle B and angle C have to be what? Which means what? They add to 90. That's the only time the sine and cosine, that's the big topic for today. The sine ratio and cosine ratio are only going to be equal if those angles add to 90. Let's put it to work. Grab your calculator for me, please. Grab your calculator. And I know it's confusing right now, but hopefully after we do this quick activity, you'll see what I'm talking about. All right, get a blank. Make sure you got a blank screen here. Plop in sine of 30, everybody. Sine of 30 degrees. And then up pops 1/2. What else could I now type into my calculator so I get 1/2 again, other than repeating sine of 30? What else could I type into my calculator that would also give me an answer of 1/2? Zoli, go. Cosine. And what was your angle?
60.
Why'd you pick 60? Why can't I pick 10, 20, 30, 15? Why'd you pick 60? Yes, they're only going to be equal if the angles add to 90. And everyone's seeing that. So go ahead, do cosine 60. Oh, 1/2. You do cosine of any other angle, it's not going to be equal to 1/2. Only if they add to 90. One more time. Ready? Let me do cosine 10. Crazy decimal. Crazy decimal. Cosine 10. What else could I type in and get that crazy decimal? If I do cosine 10, I could type in, Bailey? Sine of, not just any angle, right? Not sine of 10, sine of 15. It's got to be sine of 80, because those angles have to equal to 90. They have to be complementary. All right, we could be doing this for days. All right, everyone see how this works when the sine and cosine ratio are going to be equal, if the angles are complementary. All right, let's try a few now. I know I put some hardcore vocab in the directions. Express the following as equivalent trigonometric. Woo! All that is rewrite this using sine, cosine, or tangent. All right, rewrite this using a sine, cosine, or tangent. So I have cosine of 20. What other value would give me cosine of 20? Again, I don't want to know what it's equal. Don't write that long decimal on your calculator. Give me something else that it's equal to. Cosine of 20, the same as, Zoli? Not cosine again, sine of, and then why are we picking 70 in particular? They got to be complementary, right? They got to add to 90. And you can check that on your calculator if you're unsure. All right, sine of 37. That's going to be the same as, again, change it to cosine. We're not going to involve tangent today. It's only sine and cosine equal to each other. Cosine of, what's my angle here now? Cosine of 53 degrees. Got to be, add to 90 when they're equal. All right, we all right? All right, now let's kind of flip it now. Take a look at 3. X and x plus 20, those are two angle measures that happen to be acute angles. But look what I'm telling you. The sine of angle x is equal to the cosine of x plus 20. Find x. Well, whoa! We just went over this whole discussion. These two are only equal to each other if and only if what happens? These two angles are add to 90. Not equal. Hey, I don't want to do this. That's not what we've been saying. We have been saying sine and cosine are only going to be equal to each other if their angles, x and x plus 20, do what? Add to 90. Okay? If I see sine and cosine equal to each other, whoo, time out. That only happens if the angles add to 90. All right, so that's why we're setting them equal to 90 here. All right, you can go ahead and solve now. Whew. That's 70. X equals 35. Now, if I wanted to actually find what the angles are, you plug them back in. Okay, but I just had to find X there. If you wanted to know what the acute angles are, plug them back in. All right, how are we feeling here? Sine and cosine only equal if their angles add to, if the angles add to 90, their sine and cosine values are equal. All right, let's see if we got this now. Maybe. All right, if you want to see a visual, triangle ABC, C is the right angle, so A and B can go on the other two vertices. Cosine of A is, they're telling me, radical square root of 21 over 5. So what's the sine of B? Oh boy, oh boy. We don't need the calcs for this. We don't need the calcs. Ready? Look up above. What do you know about A and B in the diagram? C's already a right angle. So what do we know about angles A and B? Complementary, correct? Yes, they add to 90. So what do you know about these values? Cosine of one and the sine of the other. What do we know about cosine A and sine B then if A and B are complementary? They have to be? All right, let's back up. Let's back up. Cosine of one angle and the sine of another are only going to be equal if what do I know about their angles? They have to be complementary, right? The sine of one and the cosine of the other are only equal, right? Sine of, I'm just going to put a blank there, equals cosine of another if what do I know about these two right here? They have to add to 90. And what do I already know about A and B? They add to 90. So the cosine is radical 21 over 5. So is the sine of B. Hey, you ready? What do I know about B and A in this diagram? So does everyone understand why they add to 90? There's 90 degrees left. So that means the sine of one angle equals the cosine of the other one. I already know cosine of A is radical 21 over 5. So what else equals radical 21 over 5? The sine of the other angle, B. All right? Or here you go. We can do it this way too if you don't like the way I just showed there. What's cosine equal to? Let's go back to SOHCAHTOA. What's cosine equal to? SOHCAHTOA? Adjacent over hypotenuse, right? So everyone go to angle A right now. Adjacent. The adjacent side to angle A, mark it with a radical 21. The hypotenuse, mark it with a 5. Now go ahead and find the sine of B, everybody. What's sine equal to again as far as SOHCAHTOA goes? So go ahead, do opposite over hypotenuse from angle B, and what do you get? Radical 21 over 5. All right, so that's where that comes from. All right, if two angles are complementary, which they are, the cosine of one equals the sine of the other. Radical 21 over 5. All right, one doesn't make you great there. Read through number 5 now. We're picking this one up a little more here. Cosine of B equals 5/13. What else has to equal 5 over 13? Well, whatever it's complementary to. What's B complementary to? Angle A. And cosine and sine always go together with that. So it's got to be the sine of angle A. Or again, make a right triangle, right? And do adjacent over hypotenuse. Put 5 on the adjacent side. Hypotenuse is 13. And then go through each of these choices and figure out which one is also 5 over 13. All right, 6. Do I just want to set those equal to each other? No, right? You guys are getting better at this now. When is sine and cosine only equal? If those angles add to 90. So 40 minus x plus 3x, those angles have to equal to 90 if their sine and cosines are equal. So x equals 25. Oh boy, here we go. Let's see if we're really got this or not now. Whew. Right triangle, yep. Angle C is the right angle. The sine A increases. Does cosine B increase or decrease? Okay, ready? Take it slow again. What do you know about angle A and B in my diagram? They add to 90. So what do you know, ready, about those values? The sine of A and cosine of B in this problem. What do you know about it? If you know A and B add to 90, what do you know about sine of A and cosine B? They are equal to each other, right? The angles are complementary, but the sine ratio and the cosine ratio are equal to each other. That's what we found out today. Because A and B, the angles add to 90, the ratios are equal. Maybe that's the better way of putting it. If A and B add to 90, the ratios are equal. So if sine A increases, what's got to happen to cosine B if they're equal? Also increases, yes. It increases. And explain why? Well, because they're equal to each other, right? Sine A equals cosine B. If the angles add to 90, the sine cosine ratios are equal. One question on the quiz tomorrow covering all this, all right? One question on the quiz. All right, go ahead. Short homework. If you finish, you go to the Chromebook, check your answers, stay on the Chromebook, go to Delta Math. All right, so that's what we got for the remainder of the period. Finish the packet work, go to the Chromebook, look up your answers, check them, then go to delta math all the way to the end of the period.